Your database or your model provider goes slow mid-query. Here's the question that decides whether you have a resilient system. Does only that one request fail, or does the whole service go down with it? Picture the circuit breaker on your home's fuse board. When a fault draws too much current, a switch trips and cuts that circuit. The rest of the house keeps its lights on. Software circuit breakers do exactly this for your dependencies. First, see how one failure takes out everything. A search endpoint calls Postgres, which goes slow, not down, just slow. Within seconds, the pool is exhausted, and even an unrelated health check queues behind the flood. One slow dependency has made the whole service unresponsive, a cascading failure. So we build the defense in layers. Layer 1, timeouts, never wait forever. A connect timeout caps how long you wait to connect. A read timeout caps how long you wait for the response. Without a read timeout, a single hung call parks a thread indefinitely. Always set both. Layer 2, retries, done, right? Some failures are transient, so retrying makes sense. But if 10,000 clients hit an error at once and all retry immediately, the dependency faces a wave 10,000 times normal, exactly when it is least able to cope. That is the thundering herd. So you use exponential backoff with jitter. Backoff after each attempt you wait longer, 2, 4, 8 seconds. And jitter is the subtle hero, a random offset on each wait, so the 10,000 clients that failed together do not retry as one synchronized wave. The storm becomes a drizzle. Now layer 3, the circuit breaker, the hero pattern. Even with timeouts, if a dependency is down for 30 seconds, every request still waits the full timeout before failing. The breaker makes failure instantaneous once you know it's down, wrapping the call in a 3-state machine: closed, open, half open. Closed is normal, calls pass through, and the breaker counts failures in a rolling window, say 5 in 10 seconds. Hit the threshold and it trips to open, where every call returns instantly without touching the dependency. This is fail fast, microseconds instead of a timeout, and it gives the struggling dependency silence to recover. Then after a cooldown, it moves to half open and lets a few trials through. Succeed, it closes. Fail, it reopens. Layer 4, fallbacks. When the breaker is open, don't return a bare 500. Degrade gracefully, serve a cached result, fall back to a cheaper model, or at minimum a 503 with a retry after. A failure should degrade quality, not cause total unavailability. And layer 5, bulkheads. Named after the watertight compartments in a ship's hull. One floods, the other stay dry. Give each dependency its own pool, so a saturated model provider can't consume the database's connections. So the stack composes from the inside out. Timeout, retry with backoff and jitter, circuit breaker, fallback, bulkhead. Together, a dependency going down for 2 minutes causes a 2-minute degradation in that feature, not an outage of everything. That's the fuse that saves the house.